Hi,
Hi,
so I'm Arthur and I'm currently in Paris.
I'm Vivian. I'm currently situated in Vancouver.
I'm Brenda, and I'm in Montreal.
and I'm William, and I'm in Ottawa.
We're all from McGill University, but currently isolating in different parts of the world, and we're really excited to present the work that we've done over the last month.
We are thrilled to share with you what we've done for STEM Fellowship's University Big Data Challenge, for which we developed a novel network analysis pipeline to analyze social media and draw public and personal health conclusions. We'd like to begin by introducing the scope of our investigation. The challenge we identified was to assist in the progression of health decisions surrounding the COVID-19 pandemic. By leveraging resources available to the public, we wanted to see what students like us could do. The problem question we identified was, what can big data from social media platforms reveal about public activity on health-related trends? Our following investigation was an analysis on the first ever COVID-19 specific Instagram dataset. Our novel pipeline is thus a pioneering attempt in a field currently only analyzing Twitter. This culminated in the identification of real-world follow-up investigations to motivate more research along the proposed avenue. We want to create a solution that is novel, viable in the real world, and helps future study. So our objective is to leverage big data and to provide new knowledge that can support public and personal health decisions, to work together, and to create a social network analysis strategy, allowing for the identification of trends and the characterization of public sentiments.
To gain better insights from the data, we created a novel social media analysis pipeline composed of 4 key functions. Taking data collected from the HAL archives, we were able to find 5,300 international COVID-related Instagram posts dated from January 5th to March 20th. We then processed this data using the Jupyter Notebook IDE and Python 3.7. The first step was creating clusters, where we looked at the eigenvector centrality, the clustering coefficient, and used the Girvan-Newman algorithm. The eigenvector centrality focuses on categorizing a node's strength and influence on the given network. The clustering coefficient looks at the connectiveness of the clusters and how tightly related they are and isolated from the rest of the network. And finally, the Girvan-Newman algorithm provided a hierarchical community detection-based program that allowed for the cluster creations based on related hashtags. Taking all of this data, we were able to then produce more advanced insights in the following steps.
For the next feature of our pipeline, we created a fake account detector. Indeed, fake accounts have been shown to spread COVID-19 related anxiety on Instagram. Therefore, to train this detector, we used a dataset available in Kaggle and trained multiple classifiers, and in the end, it was determined that the extra trees classifier had the best performance with 92% test accuracy. Using our fake account detector and the information available in our Instagram dataset, we were able to determine the percentages of fake users, regular users, and business users for each hashtag. For the last feature of our pipeline, we classified the sentiments of both captions and comments within our datasets using a state-of-the-art BERT neural network. This model was trained on the Sentiment 140 Twitter dataset containing 1.6 million positive and negative tweets. To perform the training, we used Google Cloud servers, GPU acceleration, and the Atom with weight decay optimizer.
Using our social media network analysis pipeline, we were then able to produce the following results. Using the Girvan-Newman clustering algorithm, we were able to create Figure 4, which illustrates the 11 identified communities. Of these clustering communities, we found 3 key large and English-based clusters. The first cluster, cluster A, represents mainstream trends in the hashtags, which include hashtag art, hashtag beauty, and hashtag fitness. Cluster B represents mental health-related hashtags such as hashtag anxiety and hashtag depression. And finally, cluster C looks at conspiracy-related hashtags such as hashtag alien and hashtag UFO.
Next, we created a clustering index network. On the rightmost diagram, these 3 clusters, cluster B, mental health, cluster C, conspiracy, and cluster A, mainstream, these 3 clusters were analyzed in terms of how well their constituent hashtags were connected to other hashtags outside of the respective clusters. This is called node connectivity. From the diagram on the left, we show that a niche hashtag is not well connected with different topics, whereas a broad hashtag is. Specifically, this shows that the mental health community has a range of niche and broad hashtags. In contrast, the conspiracy community uses hashtags not widely used by anyone else.
To further analyze the clusters, our team identified business and bot accounts within the network. In Figure 8, we can see that 96.2% of Cluster B are posted by businesses. So what does this stat tell us? This tells us that the mental health support on Instagram may be linked to a marketing team's agenda. Moreover, although resiliency and mental health are linked to everyone's lives in this global pandemic, the general public are not too vocal on this topic. Another insight that we can draw from this graph is that talks on UFOs and aliens in relation to the COVID-19 pandemic are actually propagating and circulating amongst genuine users. As shown in Table 3, Cluster C conspiracy theories only contain 0.1% of hashtags by businesses. After analyzing the business account network, we looked at the presence of bots within our clusters. As shown in Figure 9 of our manuscript, most clusters are not made up of bots. In other words, our cluster analysis does indeed map out human behaviors around the globe. If we zoom in closely to Cluster A mainstream hashtags, we can see that clusters on memes, masks, and positive adjectives are often generated by bots. This tells us that in relation to the COVID-19 pandemic, memes could be a vehicle for the spread of misinformation, as well as posts about masks done by bots on Instagram.
From the sentiment analysis, we characterized the positive and negative emotions associated with each Instagram post. The top left image shows that Instagram users discussing mental health use captions with more positive language. The bottom left image shows that viewers within the mental health community also reflected this sentiment by leaving positive comments. The diagram on the right shows that posts about conspiracy theories often have negative comments, and even more negative captions. The key insight here is that mental health communities reflect positive emotions, while conspiracy communities reflect more negative emotions.
The strength of our pipeline are the following. First, it is one of the first ever attempts to analyze the public response to the pandemic on Instagram. Secondly, it uses state-of-the-art techniques currently used in industry, such as the BERT model. Thirdly, this pipeline is extremely flexible and can be used for a wide variety of research applications that involve social media data. Now for the weaknesses. One of the main ones is that we were unable to analyze non-English text. Indeed, the BERT model was trained on an English dataset. Then, for the bot detection algorithm, a small dataset was used for the training. And even though we tried to prevent overfitting, a larger dataset would give more credibility to our results. Lastly, the training set for the sentiment analysis comes from Twitter, which is different than our actual application, which is Instagram captions and comments, which might cause a mismatch between these two things.
This pipeline is a starting point for greater social media analysis and acts as a catalyst for future projects. Looking at our COVID-19 data, we believe that further characterization of pandemic behavior is possible where we can draw insightful social and economic insights. This pipeline is not just for Instagram and not just for the COVID-19 pandemic. It can be used for a variety of platforms such as Facebook and Twitter and explore several topics of interest. One we would like to tackle next is the Black Lives Matter campaign. Looking at our clusters, we believe that greater in-depth analysis and literature reviews can really unravel the meaning and importance of these clusters and these themes. Finally, looking at the spread of misinformation is another key future work that we would like to explore, specifically utilizing our bot detection program.
In hopes to better understand the COVID-19 pandemic, our team designed a social network analysis pipeline to uncover important population trends. We used account type identification, bot detection, and sentiment analysis, and arrived at 3 key insights. First, we found that within the mental health cluster, there is both the niche and broad trend. And second, amongst the mental health hashtag, the majority of them were actually done by businesses. Third, public health authorities should monitor the spread of misinformation by both bots and conspiracy theorists.
The future possibilities of this pipeline are endless, and we're incredibly excited to continue looking at social media data to create meaningful insights and conclusions that can truly impact the world.
Bye.
Bye.